Good everyone, welcome back. My last video I talked about generics. In this video, I'm going to be talking about templates. Templates is a version of generics that you can find in a programming language such as C++. Let's dive into C++ and see what templates are all about. Thank you.
Good day everyone, my name is Oguchi Beze from Environment Technologies, and today I'm going to be talking about templates. Templates are a version of generics that exists in C++, though the concept remains the same, which is writing functions using dynamic data types. Let us look at an example. This function that we have here, swap function. The swap function is written with default data types, like in this case I have int, and this swap function is going to help us to swap integers. But let us assume that I want to go ahead and swap other data types like doubles, characters, and so on and so forth. It's not going to be able to swap those data types. Now the most I can do is to go ahead and create or do function overloading here. I'm going to go ahead and create another swap function. Say void swap, and let's say I want to swap characters. In this case, I'm just going to go ahead and place in car a reference to character, and also place a. Okay, I'll correct that now. And a pointer to character B. I'll still go ahead and implement the function by saying char temp is equal to A is equal to B, and B is equal to temp. So of course this problem has been solved here, because now I have two functions, one for integer and one for characters. Of course, what the compiler is going to do is going to be able to swap the functions, or be able to pick the function, swap function, depending on the parameters I have here for A and B. So if I go ahead and change this to character A and this character B, okay, I think I have single quotes. So I just need to do is to change this to car, so I have a character, and this goes ahead and swaps those characters. Okay, we see that right here that these characters have been swapped. But then, of course, we have repetition going on here. Like we have, this is function overloading. We have two versions of the swap function, but we know we can actually go ahead and use just a single function to achieve the same aim. Of course, that's going to help us to write shorter code and make our code even nicer. So let's go ahead and use templates to solve this problem. So I'm going to say templates. Okay, I have to get this right. I'm going to place in the type name. We'll place in a variable t. So repeat a swap function inside of this case, where I have t as my type, and then type A and reference to type t for B. To get that right, and I'm going to go ahead and swap these values. So I'm going to take type temp t, passing the value of A, take the value of A and passing B, and then the value of B I'm going to pass in what is inside of temp. So of course this is going to also do a valid swap. But then what you get to find as an advantage in this case just immediately is the fact that I can have characters working using this single function. So go ahead and run this code. We'll see that this does a successful swap. And if we go ahead and change these variables from characters to integers, we'll also find it not wanted. So I'll say A is equal to 10 and B is equal to 30. Because this is integers in this case, and even though I didn't change the function any of my code, as long as the swap is concerned, this is going to work just fine. So that's the result there. So one might ask, what is going on here? What happens at compile time, at runtime? What happens in this case is anytime when we write a generic function or template function in this way, anytime we're running our code, the compiler checks the type that we need to convert our code into. In this case, we have an integer, and then it goes into the storage and creates a function, a replication of a function of the sub function using the integer type. So we don't have to worry about writing swap for integers and characters and all of that data type, when this can actually do that for us at runtime. So all we just need to do is to write template function and then go ahead and call it anywhere we need to use a different type. Of course, something as a rule of thumb that we can actually have here is to place in the data type that we want to convert our function to inside of this place. This is also fine. I choose to do this. Now, any type that you write in here is going to be the corresponding type of data to be swapped. If I have a character here, car, that means this can only take characters in this case. As you can see, we have red squiggly line under our sub function. So this in this case is an integer function. As we have templates for functions, so we have this for classes. So I'm just going to get rid of this. If I was to write class declaration using templates, I'm just also going to say the same thing. I'm going to say type name t and just create a class here. So give my class get a little list data structure with placing a private field type t, and also placing public functions. So I'm going to have a default constructor for list. It's supposed to take in data of type t. I'm placing an add function. It returns nothing. So I'm going to be able to add t. And I'm also going to place in a print function. Print. So I'm going to go ahead and implement the public functions as I have them. So I'm going to say also template type name t, and I'm going to implement the default constructor first. So first I'm going to call our class name t, and then hold on, I have the list function. The list function, of course, is a default constructor, so don't be confused. I'm going to go ahead and create an instance of t in that case, and well, it's just assign a default private field. So say t is equal to t. So the second function I'm going to pay attention is the add function. So say type name t is returned to void. I'll call my list class that I need my add function. So I want to add a data of type t. I'm not going to be implementing this function any further, so I just want that to be empty. So let's go ahead and continue. So type name t. So print function is just going to print out the value of a private field t. So I'll go ahead and remove that. We didn't specify what class this is coming from, so I have to do that now. So it's capital letter. So what I just need to do is to do a cout of our private variable t. I say end there, end line. So if I need to create an instance of this class or instantiate the class, all I just need to do is to call in the data of list type T and give it a variable name. So I just want to create a number, for instance. So a number I'm going to be creating is of type list, and I'm going to call in my default constructor here. So, and here I'm supposed to place in data type. So now I used T in this case, so I can go ahead and swap T with an integer variable. And in this case, this can take in a variable such as 10. So if I do a number.print, I will see that this prints out a number, the number 10 to the console. Let me just swap this to number 50 for variation. So go ahead and see the private field T being initialized here. So we see that 50 nicely prints to the console. Now the advantage of having generics is that we can go ahead and swap this type. So I can say character, spell right, car, and character in that way, and of course this can be hello. So in that instance, sorry, page. Okay, this works right fine. Of course, it can also be a double. Let's say double. So double can be number 40.5. So advantage still stands that we can be able to, because I have 40.5 there, we can be able to swap out the type of data that the list can take. So this gives us this advantage that we are expecting, that we can be able to change the type as we have here while we are writing our code without even having to touch the function or its declaration. Another thing we can actually be able to find out about templates is that templates can take in multiple arguments on T or for T. So let's go ahead and check that out. I'm just going to leave my template as we have it here, and add in another type name, and this time I want it to be U type. So I'm going to create a class called multi. I'm going to have a private field, private. I'm going to have T of type, private field T of type T, and private field U of type U. I'm going to go ahead and also create a public function. Of course, this is going to be the default constructor, so I'll just say multi, and that should be that. It takes in T, also takes in U as the second parameter. So I'm just going to go ahead and implement these functions. So say template, angle brackets as I have it, type name T, and type name U. Okay, I should spell that right. So now I'm going to go ahead and implement a constructor by saying multi. So this takes in T, and this also takes in U. And I'll call my multi function. In this function, I just want to go ahead and assign the default private field U, and also private field underscore U and underscore T. So this is going to take in T and U. So this works just fine, and I'm just going to come here and say cout, and constructor was called. So I'm not going to be doing any much stuff here. just want to illustrate the fact. Constructor called. Okay, I think I need to fix the U being referenced here. This is a type, so I just need to say this is one on declaration, a function, this one. So if we go ahead and create an instance of multi takes in t, you can see int and char. I want to say this is a map. So it's a map that maps integers to characters. So I just want to just create that idea in that way. So I'm going to be mapping integers and characters and codes, and my constructor, which takes in 2 arguments. I can place in 10 for my integer and b for character. So this works just fine, because if you run this code, you're going to see that our constructor is called successfully. It's going to just do this cout, not printing out the values of these variables. So it's all fine. Constructor call. So this is show that our template can take in multiple values for type name. That works just fine. Also, as we have it, we can specify the default parameter for this type name. Let's say we want this to be explicitly a character or an integer. So we can go ahead and specify a default. So just like we can do in our functions, I can go ahead and get rid of this in this case, in this way, and I'll say that this type name u must be a character. So I'll say is equal to char. So what happens in this case? What happens now is that no matter what we do, I'll just create a class called default. In this case, I'm placing a private field, just as we did before. I'll type t underscore t and type u underscore u. I'm placing public function, so this is supposed to be default. So this is the default constructor. Is supposed to take in t and u. So if we go ahead to implement the default function constructor, so type name t type name u. So it's our default constructor, so I'll call the default class. Default, this takes in t and u, and I'll call the default constructor. So what this does is it's going to initiate our private field t, set this to t, and private field u, set this to u. I'm going to add that to my parameter list just now. So what I just need to do is to go up here and say that t should come from our declaration and u should come from here too. So I'm just going to do cout again. Cout that this constructor is called. So I'll say constructor called as I did before. Now placing an end line. So if I was to create a default an instance of this class default, so this takes in, let's say, double and an int, an integer. So I'll call this a map also. And now, of course, you can see that I've been specified the character explicitly for our default. So I just don't need to add this guy. So I need to add only one. So I'm going to go ahead and call the default constructor saying default. And that way, now this is also going to take only a double. So in my parameter list, I'm going to add in a double like 10.6, and I'm just going to be passing a character here as a. So this just works just right fine. So of course, if we run this function, it's just going to tell us that constructor is called. So that's what we're trying to be sure about. So of course we say the constructor is called, and even though we have a default value for u, we don't need to specify that here. And all we just need to do is just obey an instruction and make sure that we're placing a second parameter here as a character. So that works just fine. So the last point I'm going to be making about templates is that we can actually do this some other way. So let's go ahead and see the other way that we can be able to do this. Now we can use what we call the preprocessor directive, which we call define, and that way to write functions in a way that the type is going to be resolved internally. So let's call the max function in this way. The max function takes in a and b. I'm going to check if a is greater than b, or passing a, else or passing b. So of course the type of the data that we pass for this max function is going to be generated automatically. So let's go ahead and check and see if that works. So I'm going to pass in an integer a called of value 30 and integer b of value 6. Correct that. So what I need to do is to see out the maximum of these two values. So say string maximum of values a and b is equal to, then I'm going to go ahead and check max a and b. Now see end up. Okay, so I think I should add in a question mark here because this is asking a question if a is greater than b, so I think I should have just put that in there. So all I just need to do is to run this function in this way, and I'll see I get the result that I expect. So I have that 30, which is the variable a, is actually greater than b. Of course this is right, but let's say I swap this into characters. So I can go ahead and remove this, guys, and say car a is equal to a and b is equal to b. So we'll go ahead and run this function as we have it in this way. So we can see we have b there, and of course this is also going to work for characters. So this can also work using preprocessor directive and can also work and do the work of templates. But which one are we supposed to use, or which one is better? Of course, I'm going to favor using templates here because templates can allow us to do explicit type declaration here. So if I was to write this function using templates, I'll call type name t, and I'll call my function, this returns an integer, returns a data type of type t. I'll call this maximum, takes in variable of type t, variables of type t. I'll go ahead and write that function. Say return place in brackets a is greater than b, so a question mark. Here I'm going to say return a, else return b. So this is fine. So the advantage we have from using a template in this way is that if I have to specify an integer a, I say this is equal to 60, I say b is equal to 10, and go ahead and write this maximum of, say b, actually this should be c and d. I want to have to redeclare this variable. So I have c here and I have d right here. The values c C and D equal this now going to call my maximum function. Now I can explicitly determine the type that I want to be passed into a function here. So I can say C and D. See, and now, so of course in this case, if you check in here, it's going to explicitly state that my function should take in just integers. Unlike this one happening here, of course we don't have to specify the type ourselves. The compiler has to do that resolution for us, but here we can go ahead and specify that we want this to be for integers. Of course I favor using templates over the preprocessor directive. So that's all we have time for in this video. So in the next video I'm going to talk about something new, something different. So thank you for your time and God bless.